For my final semester summary, I am going to tell you a little bit about what I did over the course of Physics 111 for the last 8 weeks. So I spent roughly 20 to 30 hours a week. So if we do 20 times 8, I'm doing 160 to 240 hours a week or in total. So I definitely spent a lot of time on this, more so than I usually do on anything else. So that's where I'll start. My first and favorite thing that we did was some of the VPython exercises this semester. VPython really showed me what parts used the physics part and how to kind of manipulate things to be what I wanted them to be. So my first one, I'm going to go ahead and bring it up. Okay, so here it is, and what I'm going to do is I'm going to run it. This is when we did the constant velocity of the different balls that went towards each other. And so there you can see that's how I manipulated it. It was one of my favorite activities that we did, more so than the initials, I think, because there's more going on in this aspect of everything. I will go ahead and show you the initial VPython exercise just to show another aspect of the VPython that I did find interesting, but not as interesting as the moving balls. So here you see me running the module, and you can see my initials, A and P. My name is Alexis Pettyjohn, and they are moving across the screen at a constant velocity. And they're having lagging colors behind them. So there is that. So my next thing that I did want to share with you was some of the different spiral kinematics that we went ahead and did. Spiral kinematics really showed me how to use math in the sense of taking spiral kinematics to the next level. So here I will pull up page 21. And here's my free motion diagram, and here you can see that the origin is going to the left and all of the action is going to the right. The acceleration is also decreasing. Here you see there's 3 separate time events, and this was a challenge for me at first, but once I kind of got the hang of it, it became a lot easier and a lot more doable. So I really enjoyed progressing from something more difficult to something a little bit more easy, such as this. I will also go ahead and show you spiral dynamics, which uses kinematics but also adds force into it. Force seemed like such a foreign concept to me when I was first asked to go ahead and do this, and I really didn't want to. But after I went ahead and did it, it turned out not to be too bad. So here you can see that I've got my free motion diagram, and I've also got my free body diagram to show the force of one object and the force of gravity or the Earth. Here you'll see the kinematics that is put into it. I went ahead and calculated all of that out, and then I used this information to go ahead and calculate the force to get 1,914 newtons. So that was my spiral dynamics. I really enjoyed doing it. Like I said before with the kinematics, dynamics also got harder as it went on, but it also built off of itself. So that really helped me learn the material. In addition, we also had to do a couple different video things, so I'll show you a couple different videos of me actually doing this course. Here we go. Here you'll see my cousin. She was helping me with my tracker analysis with a video, so here I'll go ahead and play it for her. Go. So there's one video of me doing it. We did this several times. And this is of my sister walking across the floor to go ahead and measure her constant velocity and acceleration. Here you'll see this is part of the marshmallow shooter experiment. I did record this one multiple times, but I won't show you all of them. So you could barely see it, but when you go frame by frame, you can kind of catch a glimpse of what I was trying to show you. So there's a couple of those. And then next I will go ahead and show you a little bit more of some of the projects that I did. So here is the group marshmallow experiment. I did this with Kristen and Rachel. They were great group partners, so here's a little bit about it. I went ahead and basically my test was the length of the pipe affects the velocity of the muzzle. And at the end, it became the longer the PVC pipe was, the greater the muzzle velocity of the marshmallow was. So all of these separate experiments really were interesting to see. I really enjoyed working in the group with these girls. It showed me that the length of an object will influence its velocity, its distance, all of that. Different objects will affect each other. So that really helped me. Here you can see some of the data that we did. So there is that one. That was one of the group projects that we did. And then another one we did was for our video game, full contact coding Pong. And for whatever reason, it will sometimes run on my computer and sometimes it won't. So I'll go ahead and walk you through what this Pong kind of stuff was. Here, let me go ahead and find that. Okay. So here you'll see the new and improved Pong. So what we did was we created a more edgy and stimulating version of the traditional game of Pong. And we went ahead and used the controls of A and D to go ahead and move the paddle on the bottom left to right. We added two separate paddles, one that the player controlled and one that the computer controlled. So it made it a little bit more challenging, a little bit different. It was definitely an intriguing play, and I had a lot of help from my group, Robert, Rachel, and Kristen. They were all very attentive to what we were doing, and being able to do this video game project really helped me strengthen my understanding of VPython, a little bit of the physics that went into it. And working in a group, especially in an online class, was a challenge, but it was definitely worth it. So there's the video game aspect of it. And now I'm going to go ahead and talk to you about some of the different things that we did over the course of the semester as far as our weekly little posts and such. So some of the neat resources that we did that I found really intriguing were that of dark matter and that of the metamaterials. So here you'll see the metamaterial picture that I found. What really intrigued me about the metamaterials is basically one of the biggest concepts was the invisible cloaking. The invisible cloaking really spoke to me in the fact that I didn't realize it was impossible to go ahead and make some of the materials essentially invisible to the other. So that was really cool to me. Dark matter was really awesome as well. Here you'll see some of the responses that I had to what some of the class had put down. Dark matter is basically something that doesn't have light, and the only way that we know that it's there is through its physical movement. So that was really cool to me. I really enjoyed some of these neat resources and weekly posts that you had us do because they were different. They allowed for a little bit of a break from the course and allowed me to see some of the other parts to the class. My most favorite thing that I did for this course was watching the Elegant Universe video. So here's just a picture of the universe. And I really found the Elegant Universe thing to be very intriguing because I didn't really give a whole lot of thought behind the string theory and, all of the different gravitational stuff and the quantum mechanics. So this whole video really opened my eyes to all of the different parts of the universe, all of the different theories that go behind it, and the real main goal was to try to find one mathematical equation that can sum up the whole thing. So I really enjoyed watching this video. I really appreciate you putting it up there, and I don't know what I would have done. I mean, I would have made it fine without it, but it definitely opened my eyes to a whole nother concept to our world. So that was awesome. Thank you. Okay, and finally, as I'm wrapping up, I'm just going to show you some of the notes that I took throughout the semester and what I feel I deserve as a grade for this course. I feel like I do deserve an A because I did spend so much time going ahead and working on this project, well, course. I went ahead and I made sure everything was done. Everything was done to the best of my ability. I spent a lot of time in the tutoring center for all of like the spiral kinematics, spiral dynamics, and all of that. So here I'm going to go ahead and show you some of my notes. So here's one. So here's some of my notes on the kinematics. Here's some of my notes on the different neat resources that are out there that we did. Neat resource on dark matter. Here's some of my notes for the controversial debate document that I did before it was edited and after it was edited. Here's my lab report that I went ahead and did for chapter 19. Here is these are all of the spiral dynamics that I went ahead and did, and I went ahead and took some notes on the actual pages themselves that I don't have on my computer. Here's an Excel spreadsheet that I made. I went above and beyond and made more Excel spreadsheets for ones that weren't required. Hopefully this is going to open. It might not, so I guess we'll find out. And here it is. So I did go above and beyond and try to make as many Excel spreadsheets as I could to go ahead and help me better understand the materials. Here's another one. There's another one. So I do definitely feel like I deserve an A for all of this definite work that I put into it. So here is all of that. So I did spend roughly about 160 to 240 hours on this course. So it was definitely a challenge. I really enjoyed all of it. And thank you. That is all.